Good morning, grade 11. This is Miss Teresa. This is a video guide for the Chapter 2 Motion in a Straight Line practice paper. I hope you try to answer the practice paper first before watching this video. Question 1. Two athletes jump straight up. Upon leaving the ground, Adam has half the initial speed of Bob. Compared to Adam, Bob jumps Question 1. Two athletes jump straight up. Upon leaving the ground, Adam has half the initial speed of Bob. Compared to Adam, Bob jumps. Okay, so from our choices, we are looking at high, high, high. So it means it's the vertical distance. Alright, so we're going to solve for Bob's vertical distance first. We are going to use the kinematic equation Vy squared is equal to Vyo squared minus 2gy, because this is motion along the y-axis. Okay, we're going to solve for Bob's y first. Bob's y, vertical distance. Okay, so at the highest point, highest Vy is equal to 0. Therefore, 0 is equal to Vyo squared minus 2gy. Okay, putting it in the other side, Vyo will become negative, but then 2gy is also negative, so they will cancel out. They'll both be positive. 2gy. Okay, so using this equation, y of Bob, vertical distance of Bob, is equal to Vyo squared over 2g. Alright, so now let's solve for Adam's vertical distance. Same thing at the highest. At highest, Vy is equal to 0 for Adam. So this one is for Adam. Okay, but then Adam's speed is half the initial speed of Bob according to the problem. Therefore, we are going to use 0 squared is equal to Vy initial divided by 2 of Adam, because it's half of Bob's initial velocity. Okay, squared minus 2gy. This y now is Adam's. Okay, so this will become 0 is equal to Vyo squared divided by 4 minus 2gy. Now we're going to put it on the other side. Both of them will be negative and they will cancel out. So Vyo 4 is equal to 2gy. Now we need y for Adam. Okay, so what will it become is equal to y is equal to Vyo squared divided by 2g, and then there's 4 over there. If you cross multiply, it will become 8g. So this is Adam's. Okay, now if you analyze, this is over 8. So if you multiply 4 for the height of Adam, the vertical height achieved by Adam, it's equal to Bob's y distance. Okay, so Vyo squared over 2g. So this is multiplied to 4, so our answer is 4 times as high. Question number 2, same question as the first one, but now we are looking for time for each of Bob and Adam's jump. Okay, how do we know that we're looking for time? If you look at your choices, it's time. Okay, it's looking for time. So in this problem, we're going to use the formula Vy is equal to initial velocity along the y-axis minus gt. Okay, so first we're going to solve for Bob's t. Okay, at the highest jump of Bob, Vy is equal to 0. So for our equation, 0 is equal to Vyo minus gt. If we manipulate this equation, it will become VYO is equal to GT. Both of them will be negative, so they'll cancel out. So for T of Bob, time of Bob at the highest jump is equal to VYO divided by G. Okay, now let's solve for Adam's time. Adam's T. Okay, at highest, Vy is also equal to 0 for Adam. But Adam's initial speed is half the initial of Bob's. Therefore, we will use Vy still is equal to 0. 0 now is equal to Vyo divided by 2 because half the initial speed of Bob minus GT. Manipulating it, we will have Vyo divided by 2 is equal to GT. So now T for Adam is equal to Vyo divided by 2 divided by G, and then simplifying it, T of Adam is equal to Vyo divided by 2G. Now if you manipulate it even further, it means that if you multiply twice to the time of jump of Adam, it will be equal to Bob's jump over G over here. Okay, so it means that you multiplied it to 2, so your answer will be twice as long. Question 3. A car is traveling due west at 20 meters per second. So this is motion along the x-axis, so we'll denote it as Vx initial velocity, negative 20.0 meters per second. This one is negative because it's due west. Direction is important. Find the velocity of the car after 3 seconds. T is equal to 3.00 seconds. And if its acceleration is A is equal to 1.0 meters per second squared due west, again this is negative, assume that the acceleration remains constant. Okay, so we're looking for Vx. This is unknown. So we're going to use the formula Vx is equal to Vxo plus Axt. How do we know that we are going to use this formula? You have to look at your given and find in the kinematic equations which fits your given best, including the unknown. Okay, so we're looking for Vx, and this equation is the only one that makes sense. Therefore, Vx now is equal to Vxo is negative 20.0 plus Ax is negative 1.0 multiplied to time, which is 3.00. Then you're going to use your calculator and you will get negative 23 meters per second. What does the negative mean? Negative means that it is in the west, because if we have our directions over here and E, W, S, N corresponds to the positive y-axis, and then south corresponds to the negative y-axis, east corresponds to the positive x-axis, and west corresponds to the negative x-axis. Alright, so this means that the Vx is equal to 23 meters per second west. So our answer is letter C, because that's 23.0 meters per second west. Question 4. A car is traveling due west at 20 meters per second. Again, this is along the x-axis, and Vx is equal to negative 20.0 meters per second. Why? Because it's due west. Find the velocity of the car after 37 seconds. T is equal to 37.00 seconds. If its acceleration, A, is 1.0 meters per second squared due east, so this will be positive. Okay, assume that the acceleration remains constant. Still, we are looking for Vx. This is initial velocity, this is final velocity. Still, we're going to use the equation Vx is equal to Vxo initial plus Ax acceleration along the x-axis times time. So Substituting, VXO is negative 20 plus A is positive 1.0 multiplied to 37 seconds. So if you add this together using your calculator, you will have the answer 17 meters per second. And since it's positive, okay, it means that it is east. Okay, so our answer here is letter B, corresponding to our answer. Question 5. An electron starting from rest and moving with a constant acceleration travels 1 centimeter in 2.0 milliseconds. Alright, so we have centimeter and millisecond over there. What is the magnitude of its acceleration? Now, if you look at your given, they are both in centimeter and millisecond. And then your choices, you have kilometers and second. It means that you're going to convert centimeter to kilometer, because kilometer is there in your choices, and then millisecond to second. So let's do that. We have VXO, initial velocity here, because the electron starts from rest. So it's 0 meters per second. And then constant acceleration travels 1 centimeter. It means that that's your final position. X is equal to 1 centimeter. If you're going to change this to meter, kilometer. Okay, you're going to change this to kilometer. Multiply it by 100 centimeter. This is your conversion factor is equal to 1 meter. And 1,000 meters is equal to 1 kilometer. Alright, so this distance is equal to 1.0 times 10 raised to negative 5 kilometers. And then your time is equal to 2.0 milliseconds, which milli means 2.0 milli means 10 raised to negative 3 seconds, and that's enough conversion for it. We're looking for A along the x-axis. Okay, x-axis, so that's unknown. We're going to use the formula x is equal to xo plus VXO along the x-axis times time plus 1/2 acceleration along the x-axis times time squared. XO is 0 because it starts from the origin. Vx is 0, so this will become 0 as well. Therefore, our final equation will just be x is equal to 1/2 ax times time, where 1/2 a is not given. That's the unknown. We need ax. Okay, we're going to substitute x now with 1.0 times 10 raised to negative 5 is equal to 1/2 times ax, acceleration along the x-axis, multiplied to 2.0 times 10 raised to negative 3. Okay, using your calculator, you will be able to find that a along the x-axis is equal to 5 kilometers per second, which corresponds to letter A. Question 6. A car travels at 22 meters per second north for 30 minutes and then reverses direction and travels at 28.0 meters per second for 15 minutes. What's the car's total displacement? Now, if you look at your given, you have meter per second here, but then your time is in minutes, so be sure to convert minutes to seconds first before solving. Okay, it says that in the problem, the car starts going north first at 22 meters per second. Okay, so that's the positive y-axis, and it's at 30 minutes. Therefore, that is multiplied to 60. 30 minutes times 60 is equal to 1,800 seconds. So the time 1 is 1,800 seconds. And then reverses from here, it reverses direction and travels at 28.0 meters per second. So this is negative 28.0 meters per second. And the time 2, T2 here, T1 here, time 2 is equal to 15 minutes. 15 minutes is equal to 900 seconds. Okay, now we're looking for the car's total displacement. The total displacement over here is delta y is equal to y2 plus y1, and y2 over here, distance times it's y2, that's distance. Y2 is equal to the formula that we're going to use is v times t, because distance is equal to velocity times time. Alright, so y2, in this case d is y, because we're moving along the y-axis. Okay, velocity times time. Velocity 1 is 22 meters per second times time 1 is 1,800 seconds, plus velocity 2 is negative 28 times 900 seconds. So if you add them together, you will get delta y. Let's move over here. Okay, delta y will be equal to negative 14,400 meters. Okay, it's negative because it's going on the negative y direction. Then of course you don't have those in your choices, but just mind the magnitude over here, not the direction. So if you change that to scientific notation, it's equal to 1.44 times 10 raised to positive 4 meters. So the answer is A. Although it doesn't have a negative sign, okay, displacement is a vector quantity, so it has a negative sign because it denotes the direction. It's going down. The question did not ask about direction anyway, so your answer is letter A. 2.8. A car moving at 60 kilometers per hour comes to a stop in 4 seconds. What was its average deceleration? So we have a given first 60 kilometers per hour, so that's your VXO. And then that will be 60 kilometers per hour, and you know that it's in kilometers per hour, but your choices are in meters per second squared, so you have to convert this. So the conversion factors are 1 hour is equal to 3,600 seconds, multiplied again to another conversion factor for the kilometer. 1 kilometer is equal to 1,000 meters. Or you can just do it easily in your calculators if you have the automatic conversion over there. Otherwise you can do it this way, and then hour and hour can be cancelled, so this is actually equal to 16.67 meters per second. It says that it comes to a stop, so your Vx, the final velocity, is equal to 0 meters per second, and your given time t is equal to 4.0 seconds. The formula that we can use for this is average acceleration is equal to Vx minus Vx initial over the time interval. So substituting the values, we will have 0 minus 16.67 divided by 4. Then you will get the answer, which is equal to negative 4.17 meters per second squared. So it's negative because it's deceleration. Okay, but in your answers, in the choices, you only have what? You have 2.4, you have 15, 4.2. So of course we will choose 4.2. Okay, it's already called deceleration in the problem, therefore we can safely choose 4.2. Alright, that's the answer. 2.9. You drop a rock from a cliff. If air resistance is neglected, which of the following statements is or are true? So there is a rock, you're from a cliff, you're in a cliff, and then you're going to drop the rock. Okay, the acceleration due to gravity will be acting on this. It will have a constant acceleration, 9.81 meters per second squared. If it has an acceleration, it means that v, the speed, the velocity, is increasing. okay, and the acceleration is constant, which is 9.81 meters per second squared. So let's look at the statements. Statement 1, the speed of the rock will increase. Yes, as we have said over here. The speed of the rock will decrease. Nope, because it's increasing. The acceleration of the rock will increase. This is wrong. Why? Because g is constant, the acceleration is constant, and the acceleration of the rock will decrease. Of course not, because we just said it is constant. So the answer is the first statement only. It is true. Now you be careful again if the question will ask you which one is not true, okay, and which one is true, which one is false. You have to be careful about these types of questions. Okay, so the answer here is A. 2.10. A car travels at 22 kilometers per hour for 15 minutes and at 35.0 kilometers per hour for 30 minutes. How far does it travel overall? Okay, so the question will use the equation x, distance is equal to velocity times time. X is equal to vt. Just distance is equal to velocity times time. It means the same. Okay, so the givens are, we have v1 is equal to 22 kilometers per hour. It's in kilometers per hour. Therefore, our time, which is given in minutes, we have to change it to hours. So t1, 15 minutes is 0.25 hours. And then v2 is given at 35 kilometers per hour. Okay, and then the time 2 is equal to 30 minutes, which is 0.5 hours. Okay, so the total distance covered by the car is equal to v1 times t1 plus v2 times t2. Okay, so v1 is 22 multiplied to 0.25 plus v2 is 35 multiplied to t2, which is 30 minutes, that is 0.5 hours. So your total will be equal to, if you use your calculators, 23 kilometers. Okay, so that's the total distance covered by the car, which is letter A. 2.12. The figure describes the position of an object as a function of time. Which one of the following statements is true? So you're given a position time graph. So if you have a position time graph, you can say that in here, if it's flat, okay, the object is at rest. But if the object is having this graph, okay, inclined to the right, it means that the velocity or the speed is constant. All right, so if we're going to analyze all the statements, we're going to start with letter A. For example, the position of the object is constant. No, because there's part 1 and part 2. Part 2, the object's position is not constant in that case. It's increasing with respect to 0 position. The velocity of the object is constant. No, because at this point, this one, there's no velocity here, 0 velocity. The object moves in the positive x direction until t is equal to 3 seconds, and then the object is at rest. It's not true, because at part 2 of the graph, it's not at rest. So this is wrong. The object's position is constant until t is equal to 3 seconds, and then the object begins to move in the positive x direction. That's correct. And then the object moves in the positive x direction from t equals 0 to t equals 3, and then moves in the negative direction. This is wrong. So there's only one true statement, which is letter D. Okay, let's refer to this figure for 2.13. Which of the following statements is true at t is equal to 1 second? So we are concerned with this point of the graph, t is equal to 1 second. Now this is a position time graph. How do you know? Because the y-axis is x, which means position, and it's measured in meters. So that's position, and this is time. Okay, so this is position time graph. Three things actually. Three things that you need to know about position time graph, x, t. Okay, position time graph, if this is your line, this is positive velocity. Okay, positive velocity. If you have this graph, this one, it means that velocity is equal to 0. It's at rest. Okay, it's at rest. And then if you have this type of graph, this one, this is negative velocity. All right, but in the given, I'm gonna erase this. All right, so I hope you remember those three things that we need to know about position time graph. But in our graph, the given graph is a curve, so we'd rather draw tangent lines from the points that they'll be giving us, which is t is equal to 1. So if we're going to draw a tangent line from there, okay, so this is our line. Now if we solve for the velocity of a position time graph is the slope of that line. Okay, so the slope of the blue line will be positive. Therefore, we can safely answer that the x component of the velocity of the object is positive. All the other statements are wrong. 2.14, this is a continuation of the previous slide. Okay, now we're going to look at t is equal to 4 seconds. Which one of the following statements is true at t equals 4 seconds? So this is the 4-second point. And then if we're going to draw a tangent line over there, okay, this is our tangent line. Now the velocity of this will be negative, as I have told you. Therefore, the answer for number 14 will be D. The x component of the velocity of the object is negative. 2.15, it's still a continuation of the same graph. Okay, now we're going to look at t is equal to 2.5 seconds. This is t at 2.5 seconds and it corresponds to this point on the curve. Okay, and then if we are going to draw a tangent line to that point, it will look like this. This is the tangent line. It's a straight line. In a position time graph, if you have a straight line, okay, and this means that the v is equal to 0 meters per second. So the answer here will be the x component of the velocity of the object is 0. Why not acceleration though? Because I'm sorry about that. Because we can solve, this is vt. If we have a vt graph and we solve for the slope, that's the acceleration. But for a pt graph, pt means position time graph, if we solve for the slope, that is velocity.